Can you hear me? Is that better?
Yeah.
Okay. I find it helps to have a little speaker here, even though it's a small room, especially with the live stream. So we. All right. Well, once again, thanks for coming. I'm glad everybody made it out. We haven't met for. Well, we haven't been here for 2 months. February we had a snowstorm we just canceled, and last month we live streamed from our houses, which worked out pretty well. So I'm glad to see new faces and familiar faces. So my name is Michael. Those of you that don't know me, Kevin and I run this meetup once a month. We meet first Wednesday of every month. If you are looking for us online, our website is FullStackTC. All of our handles are FullStackTC. We also have a YouTube as well. So this is live streamed to Twitch, and then it'll be up on YouTube as well. And then all the talks are referenced on the website as well, with links to the notes. Notes are on GitHub as well, and a link to the video. So just a quick shout out to our sponsors. So Wildlands for sponsoring this, helping us get put this on. Wildlands is hiring for a digital marketing person with experience in SEO analytics. So if you go on their website, Wildland, you will see a link to, actually, that's the link. You will see a job posting for that position. If you know of anybody, they are looking. And of course, Fuse for allowing us to use their facility. All right. So Tri-City Game Devs, this is Kevin's. Do you want to do a plug?
Sure. So, yeah, Tri-City Game Devs is a newer thing we're doing. It's kind of like a community of game developers that come together and work on projects and progress on projects over time. It's once a month. And yeah, we'd really love to see you there if you're into game programming or asset development or music or story building, any of those things. We'd love to have you.
When is it usually held?
So it is, as of now, the first Friday of every month. So it's actually this Friday too. So 6 to 10 here, same place.
6 until people go home. So we start off.
6 until people go home.
We 6 to 10. We start off with just a short talk, and then people can break out and do mentoring, collaborating, working on their stuff, socializing, whatever it is they want to do around the game development community.
Yeah. Fritzy will also be speaking on Friday, so he's the man. Give him a high five.
Thank you. Yeah. We can
Forgot there's people in there.
I'm sorry. I want to have a calendar so that we know what's going on in the new room, because you never know.
You were so quiet, we didn't hear anybody.
Well, I saw this come down.
All right, so moving on. I like to throw in a quote just to help inspire people about continuing your education. So anyone who stops learning is old, whether it's 20 or 80. Henry Ford said that. So one of the reasons we started this meetup is to network and learn and continue our own personal education. So I encourage you guys to keep doing that, keep coming out to not just this meetup, but all meetups. All right, next month, I don't know if Trevor wants to speak next month, but he did submit something.
I don't know if I will be ready with my day work job.
Okay.
But maybe my next month I can know if I can take the next month after that.
Okay, so June might be taken, but next month is available if anyone wants to talk. If you do, reach out to me or Kevin, or just submit it on the website. So today, Nathan Fritz will be giving a talk using Postgres. Our speaker that we had lined up for this month had to cancel from coming down from Seattle, and so Nathan generously agreed to do this last minute, literally like 24 hours ago, so thank you. But before I have him come up and get started, I was hoping everybody can go around, introduce themselves, who they are, something they've been working on recently, and anything else you'd like to add. So, Chad, want to start?
Okay, I'm Chad. I work for Arcana now. I'm working on learning how to write in PHP system. started because I came from running the co-op process for React app.
Hey, I'm Lance, hobbyist programmer. I currently enjoy making games under small stuff in Python and assembly for games right now.
I'm Keith Showalter from Global, and been on secret data stuff for Century 21. Some really run projects.
I'm Rick. I broke myself, so I'm going through retraining 52 to become a front-end developer designer. In the beginning of the second year of school.
I'm Trevor. I'm a half-ass programmer, and the presentation that I make you pretty soon will be utilizing Ubuntu 18.04, doing a combination ZFS, RAID, and LVM2 install for like home server stuff. So if there's anything people want me to focus on that, let me know as I create this presentation.
I'd like for you to focus on 1904.
1904. I'm only focusing on LTS because that's what I use.
Okay.
Software RAID.
Software RAID, LVM, and ZFS on Linux, which is now in 1804 Ubuntu.
Cool.
Someone,
Again, Tim Black, new guy in town. I grew up in the Tri-Cities, came back partly because I know it's a better job environment or job market here. And I am looking for more work as a web developer. The past 2.5 years I worked as a web developer for an option trader. And he teaches people how to use his methods and write software that implement his methods. So that involved a lot of back-end and front-end work. But I think some of the interesting stuff was on the front end. Use the Black-Scholes formula to predict and everybody in finance should know about this, to predict the price of an option at its expiration date or at its closing date based on where the underlying market is. And anyway, then the option trader allowed to layer multiple options together to eventually try to project that you'll make a profit from that level. And so the interface helps you to do that. I found it interesting.
I'm Nathan Fritz. I'm going to talk today. I'm the chief architect at Ambient here at Fuse. Something I've been working on lately, doing a lot of video conferencing, WebRTC stuff at Ambient through a product called Simple WebRTC. And I've been exploring a new programming approach for games, well not new, but new to me, entity component system. And I'm going to be giving a talk on that on Friday.
Mike Tyler, I'm a mechanical trade with a game I made and mobile apps that always try to put off the ground. Never seen me with a tough time like that.
Okay, I can do that.
I'm Bryce. Originally from Australia. Just moved here about a year ago. Currently studying computer science. School keeps me pretty busy. Outside of that, I can have a little React and VMworks.
Patrick Sutton, originally from Virginia, been here about 2 years now. Worked for a small company in Virginia. Kind of worked, at least in passing, with a lot of the higher level languages like Java, C, PHP. Recently I've been working on Spring Boot applications in Java. Pretty much it.
Kelly, currently work for a blockchain game development company.
just nurse code. I don't know about game dev, but I build apps to support the games. Been working with Vue and so on.
Cool. All right. Well, Nathan, it's all you. Oh, if anybody wants to join Nathan and I, we're gonna go down to Foodies for a beer after. So, if you're interested, just don't forget to turn on.
You mentioned Foodies, Mike, but I'm probably not going to be able to make it.
I'll let it slide this time.
You let it slide this time, all right. Okay, so this doesn't have a headphone on it. It's just. What's it supposed to go by?
So I think the other way, so this should go on the other side. Yeah. So it goes right over your ears.
Okay, so this goes like this.
And then make sure it's on, because it might be on. So you might have to slide it all the way to the side.
Okay.
Oh, there we go.
Check.
Yep, you're good to go.
Kevin, you got background music going there.
What?
Oh, he knows.
Background music. Comes with Sonos or something. Thank you.
Okay. Okay. So, using Postgres to great effect, a series of rabbit holes by me. So I already introduced myself, but for the purposes of this, I'll do it again. I'm Nathan Fritz. I'm the chief architect at Endyet, and my emojis stopped working when pressing the present button, so I apologize for that. And I'm Fritzy on Twitter. Feel free to email me. And yeah, again, a plug for the Tri-City Game Dev Club tomorrow. Kevin asked me to do this last minute. We've got 46 slides, but really 23 slides because of title slides. I haven't had a chance to practice this, so it might be 30 minutes, it might be 70 minutes. We'll find out. We'll find out together. I've been at Endyet for 10 years. We use Postgres as our primary database, but we're familiar with a lot of databases and use a lot of databases. Feel free to interrupt me during the talk for a quick question. But otherwise, if you think it's kind of a deep dive, we'll wait for the questions at the end. So, a series of rabbit holes. And what I mean by that is we've got a lot to cover. This isn't a workshop, and it's not going to be enough information for you to learn Postgres by itself. That would take several days for SQL alone, but this will be enough information to get to know the landscape and features and how to apply them for Postgres. So these are just the titles of the sections. We're going to start with what it is, what are the features, what are the tools, overview of running queries, stored procedures, triggers, my favorite type, which is the JSON type, which we'll get into. Weird features like publish subscribe, which you might not know that the database had. How to optimize it, use indexes, and then some hot takes and opinions about how to use Postgres. So, what is Postgres? Postgres is open source, it's transactional. So what does atomic mean? Atomic means that I can do a set of actions without being interrupted by another set of actions safely. So I can run these transactions that might read from a database, write to the database based on the read. If that read had changed because of another write, then my new write doesn't make sense. So atomic means I can do things like that safely. Postgres, unlike a lot of databases, uses multi-version concurrency control, which means it's kind of like Git or SVN, in that every time you do a transaction, it makes a new fork, so that you can get these transactions written really quickly to the disk. The downside of that is it has to be cleaned up every once in a while. Postgres has a vacuum job that it does every once in a while to clean up the database so it's not this giant change tree, and in fact it just vacuums it back down to just the state of the database. Let's see. Transactions mean we can do a lot of naturally atomic things in one atomic action. And Postgres started off as an ingress database in the early 90s by Berkeley. And I don't think it has any of those features anymore. So it's been an evolutionary process. They added SQL support later. And yeah, the Postgres's main feature is that it has a lot of features. It will do pretty much anything that a database can do. So one of the sets of features are its types. Types are, in this case, things that we can evaluate or store in columns of the table. So you can see there's quite a few types. Some interesting, and a lot of these types are standardized across lots of SQL databases. Some things to note are that, like varchar, if you're familiar with like MySQL or MSSQL or Oracle DB, use varchar a lot. In Postgres, people don't tend to use varchar very much because the way it stores things is exactly the same. The way it indexes it is exactly the same. It just kind of truncates it for you or produces errors based on it being a varchar. So most Postgres people just use the text type. But there are a lot of types. Some of these types I haven't even put in here, but there's all sorts of like IP address, IPv4, IPv6 types, or MAC address types, range types, domain types, and then like container types like JSON and arrays and things like that. So there's just a wider range of things you can store in a normalized, strongly typed way. Extensions can add types. So one of the most popular extensions is PostGIS, which is an extension that gives you geographic global types. If you're measuring things on the surface of a globe versus a flat Earth, you're going to get different results. So Postgres core has some regular geometry in it, but PostGIS adds sort of global latitude, longitude types and ability to query based on like ranges or shapes, geofencing, that kind of thing. Timescale is actually an extension by a company also called Timescale. And a timescale database is essentially, a log, but you might want to do specific things with it. It's a time-based log database where you might want to automatically summarize and aggregate and things like that. So that extension does that. Ltree is an extension that I've used in, say, a forum API. So it's this, it's kind of like a cookie trail, sort of a crumb trail rather, type. So you can say, I was here, I was here, I was here, I was here. Or in this forums case, I was at this forum ID, inside this forum ID, inside this forum ID. And then CI text is useful for email and stuff. It's basically case insensitive text. So you can put in caps, lowercase, mixed, whatever. It only thinks of it as one type. So when should you use Postgres? And the answer is just use Postgres. So Postgres, what it's good for, it's really good at optimized reads. It's really good at exploratory reads. So you have all of this data, and you've either optimized it for specific types of retrieval, or you haven't optimized it and you're just exploring the data. Scaling writes takes more work because every table needs a primary node that it writes to. So unlike maybe DynamoDB or React, you can't just write anywhere in the cluster. For a given table, you have to write to a specific place. Now there's all sorts of tools that take care of that for you, and there's failover procedures when your primary node for a data source goes down, and that kind of stuff. But in general, it's a little bit harder to optimize for, like, if you're trying to write millions of times a second to the same table, Postgres isn't the right answer. There's ways of getting around that, but again, it's more work. Let's see. Postgres has some table sharding features that are brand new that we'll get into later that makes some of this scaling easier. And again, if you're writing thousands of times a second, you're okay. Millions of times a second, not okay. It can be used as a document store. It can be used for all sorts of, oftentimes when I have a big dump of data from some service, I just load it into Postgres and then explore it. So anything you can do with a spreadsheet, you can do with a database, if you think about it that way. I'm not a fan of advocating a specific technology for everything. Really not. It's kind of a joke, just use Postgres. It's so true for 95% of the apps out there, though. Just use Postgres. But in general, use the best tool for the job. So there's got to be cases where Postgres is not good. So maybe don't. You probably shouldn't use Postgres if your company doesn't use Postgres. There's nothing wrong with Microsoft SQL or Oracle database. Those are great tools. Postgres is just an open source competitor to that, and it competes very, very well. In fact, lately, the features that Postgres has been getting, the other databases have been trying to catch up. And that's also true in terms of optimization features. So it competes very, very well with these proprietary databases. If you're a .NET studio or a .NET company, they probably provide you Microsoft SQL servers. Just use that, you're okay. You don't have to rock the boat. Other times that you wouldn't use it, again, is super high write scale. If the trade-offs of making that work in Postgres are worth the trade-offs of not. So like in DynamoDB or React or something like that, where you can just write, you can just add servers horizontally and write to your heart's content. You can, oh, my writes aren't keeping up, add a server, writes aren't keeping up, add a server. The problem with that is, in a document store like that, you, as the application writer, have to deal with the conflicts. And programmers, I've met very few programmers that are good at that. And it comes down to taking each type of data that you have and knowing, I've got 3 versions of it. How do I pick the one I like or create a new object that merges those all together in the right way? And that's a case-by-case basis. So that's a lot of work. But you can, if you need, if you're AT&T and you're writing all of your SMS messages to a database, you probably wouldn't use Postgres. You'd use a document store. You can deal with content. Conflicts are pretty simple with that kind of data type. Everything is pretty straightforward. Don't use Postgres if it's ephemeral data, meaning data that goes, don't use Postgres as a cache. Don't use Postgres to make something faster. There are better tools for that. Don't use Postgres in embedded environments or in standalone applications. So if I made a game or an application that runs entirely on someone's desktop, I would use an embedded database. I wouldn't use Postgres. Postgres is its own service that runs as a separate service, and you don't want it as a dependency of your embedded applications. So yeah, those are all the cases that you wouldn't. Now think about the apps that you want to write. Almost always, Postgres doesn't apply to any of these things. So just use Postgres. How do we run Postgres? Well, first, we have to install it. And there's a bunch of ways to install it on all the platforms. There's essentially like low-level ways to install it and high-level ways where it runs in an application. So as a developer, that may running it as an application is really convenient as a developer. Running it as a service is obviously how you'll run it on a server somewhere. So I primarily use Mac OS these days, or Linux. And so on Mac OS, I used Postgres.app. On Linux, I just use my package distro and install it that way. And it gives me a few tools. And unlike other databases that you might be useful, like Microsoft SQL, it doesn't give you much. It gives you some CLI tools. It gives you a directory of 20 CLI tools. But the most useful ones are PSQL and pgdump. And that's about it. And so you may want a UI tool. pgadmin is by far the most popular. I like to mess around in Vim all the time, so I use this Vim plugin, VIP SQL, Post2Co, etc. What does a UI give you? Well, pgadmin lets me do everything in UI forms, but most of these just give me the ability to run a query without having to and run a query again without having to copy and paste. Just being able to say, oh, here's the set of queries I have. Let's tweak them in an editor and run them, rather than like the PSQL command where it's all in a command line. Some query basics. Again, I'm not going to teach you SQL, but we're going to go over some of the basics so that you understand its capabilities. Any questions so far, by the way? Nope? Okay. So, some basic things that we need to do is in our database we have tables. Tables are just rows of the same type. So we make a series of columns, each with their own type. That in and of itself is a type. Each of our rows is going to be identical as far as the type of data you store in a given table. So the create table syntax is pretty straightforward at a basic level. We say create table, then we say the name of the table. Then in parentheses, we have a list of the names of the columns of each column followed by the type of each column. So ID is just a name. Serial primary key means I want this ID to auto increment. I don't want to have to set it myself. Primary key sets an index on it for me so that I don't have to separately set an index. The name is just text. Birthday is a date. So there's lots of types. The more you use, if I just use text for everything there, it would work, but I'd have a lot harder time querying by date range. It would be a lot slower to look up something by its ID. And why would we want to look up authors by ID? Well, look, let's create a second table. And it looks very similar to our first table, except that we have a constraint called references. So this author ID references the authors table ID. So this is called a foreign key. And a foreign key keeps things, again, atomic and safe. So that if I were to remove this ID, I could get an error. I could set all sorts of conditions that happen if I break the relationship somehow. I can say, hey, just delete the other one if I delete one. If I delete a book, I should delete the author of that book. Maybe I would want that, maybe I wouldn't. So I can define those things. So it just creates, a foreign key creates a constraint that says this has to reference something from that. I can insert into a table with insert into, then the columns that I'm going to specify. Notice I didn't specify ID. I don't have to specify all the columns. Sometimes we can put additional constraints on something. I could have set name as not null, which means you have to specify it. But I didn't do that, so I don't have to specify a name here if I don't want to. But I said I'm going to specify the name and the birth date. I'm going to give it these values. So that created a row in my authors table. But now I want to create a bunch of rows in the books table. And I can do that as separate queries, or I can do that as one batch. So I can say insert into books. Again, the old same syntax that we used for the other one. I'm assuming the ID is 1 here. You probably actually want to know for sure. But I'm just assuming that right now. If you're doing a real transaction, you get the row that you went to reference, and then you use the ID. So I'm going to add a couple books. So I added 1. I said using Postgres to great effect, but I actually have another one. Burritos, not just for eating, and burrito essentials. So I'm inserting 3 at the same time. Why would I want to insert 3 things in one statement? Does anyone know? Go ahead.
So one of them fails if they were dependent on, I guess, like, on each other, or somewhat related, I guess, part of the series. A book, I guess, is part of the series.
Sure, I may want to keep it atomic. I might want it to be a transaction. If one of these fails for some reason, say I have some rule somewhere in my database that this breaks, that one of these rows breaks, I want them all to fail. That's a good reason. Yeah.
It's also much faster often to insert in bulk rather than one at a time. And I noticed that they all have the same author ID, so that might be a practical reason in this case.
Sure. Yeah, and the thing you hit on there was key, the first thing you hit on. Remember, we're running Postgres as a service. It has a network connection to it. We're going and saying, hey, do this thing, and it goes, okay, I did the thing. And Postgres is very, very much about safety. It's not going to come back and say, hey, I did the thing, unless it's written to disk. And not just told the OS to write it to the disk, and the OS said, oh yeah, things are okay. No, like, the file system is synced. It came back, it's written to disk. So if we do all these individually, that's this dance that we have to do over and over and over again, and there's latency to that. But if we do it in batch, we can do it very, very quickly. Now, when I say latency, we're talking, 4 milliseconds at a time here, plus your network latency. But that batch is much, much faster. So, for example, at end-yet with simple WebRTC, we're logging all of this call data for stats. We anonymize it, then we log all these stats. And we're logging it into memory at first, but then once it gets big enough, say we get 500 rows of data or whatever, we generate an insert statement and we batch it all up. And at a protocol level, there are optimizations there too, but we're not going to get into that today. So here's a select. I want to know all of the author names, and I want to know all of their books. I could just select, you've probably seen this before, select star from authors, right? That would only give you the authors. And star would mean all the columns. Here we're going to select the author.name and the book.title from authors. We join, and by default, joins are left join, and I'll get into that in a second. We join to books, this other table, on this foreign key relationship. The author's ID is equal to the book's author ID. And just like we said, it referenced that. So we get all of those. And then in our where clause over here, we say, what are all the rules? What are all the filters for which rows we get back? And I said, oh, just, authors from the last century. Old people. So that gives us our results. We get a table that comes back. I'm sorry I didn't render this out. We get a table of Nathan, Fritz, and book title. And another row, Nathan Fritz, the other book title. Nathan Fritz, the next book title. So, let me talk about joins real quick. We can have the basic two types of joins are left joins and right joins. So left just means the first, starting at the first tables we mentioned, and right means starting at the other tables we mentioned. If there are nulls, if there are rows that don't match on the secondary table, we may get, for example, Nathan Fritz, null, 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 null. In this case, it doesn't matter. The relationship is pretty strict. So let's move on. And if you didn't understand any of that, that's okay. There's lots of materials to learn SQL. And I really, really recommend you take the time to learn SQL, because this is a language that's been around for 30 years. It's going to continue to be around for the next 30 years, and nothing has effectively replaced it. We have ORMs and object relational managers, and I'll go into ORMs later, but they are an abstraction that make databases seem more friendly to programmers. They seem like the types of data that programmers more regularly use. But SQL is hard to replace, and I recommend you know it, because then you'll know how to query a lot of things. You'll know how to query, even an Excel spreadsheet has SQL interfaces. Like you'll know how to query anything effectively. So let's look at advanced queries. In advanced queries, I can group by things. I can sort, I can group, I can aggregate things together. So I can get the sum of things, I can get the average of things. I can bunch things up into an array in a single column. I can build a JSON object. I can do whatever. So I can aggregate over multiple rows and squish it down into fewer rows. And we use group by to determine how much we squish those rows, like which rows do we summarize? Do we summarize it when they're all from the same company? Do we summarize it when all these rows are the same, whatever? And then there are window functions, which are similar for breaking out relationships between data and other queries. There's recursion using CTE, so we can actually say, we can like follow, we could make a graph by saying, this row links to this other row, and then that row links to this row, and then that row links to this row. We can follow that recursively using a CTE query. We can look at a group of things and decide, is this value in this group of things? We can do subqueries. So it gets really complicated really fast. I actually want to show you aggregate functions. So up here are array aggregates. You can have average. You can bit and things together, or bool and things, bool or things together. You can count. You can create JSON arrays. You can create JSON objects based on multiple rows. So you can aggregate all these rows together with all these different functions, and there are a bunch of them. So select XML ag from, here's a subquery. We select a bunch of stuff as tab. This will return one row with all of the data in XML form. If we wanted to group and have multiple rows, we'd do that differently. So here's even more aggregate functions. These are statistics-based functions, if you like statistics. Ordered set aggregate functions. And things that I don't understand, like hypothetical set aggregate functions. There's just all sorts of ways of aggregating your data. So you take aggregating is just taking multiple rows, applying functions to them, and getting less rows that summarize your data in some way. So, did I lose my presentation? Let's see. And then using with, the bottom one, I think. Here's a recursion. Here's a recursion where we go through various links. So, I think is it? Here it is. So we're gonna, here's our table type. We just invent a row type, and it's all of these things. We're gonna give you back all of these values. And we're gonna do it by selecting these values. And notice there's some links here, and then we can union all, and then we'll select again based on those link IDs. And so it will recursively walk through. It starts with this query and then recursively does this over and over and over and over again until it gets to the end. And it gives you the results. So that's like an example of a more complicated recursion query. Again, I know this looks overwhelming. There's a lot to it. But simply, you can start off with just simple selects and joins and get a lot of mileage out of it. Let's see. So moving on to stored procedures and functions. So we can create a function that gives us maybe an easier to reason about interface to something more complicated. We can abstract, we can hide some things behind a function name. So if we were to select, if we made this function and said select 2, it would return a column called of 3, because it's return I plus 1. And so we can write these functions in a bunch of different languages. We define the language here. This is PLPG-SQL, which is very closely compatible with PL-SQL, which is Oracle's procedure language. We could write it in just SQL. We can say the language is SQL. We can say the language is Java, and if we have the Java extension installed, we can write Java in these functions. We can say it's JavaScript. We can say it's Python. We can say it's C. And so there's a lot of supported languages here, and I recommend learning PLPG-SQL. It's very close to SQL, and it's really powerful for dealing with data. And we'll get to some more interesting functions in a little bit. What we can do with a function is we could run a bunch of queries and put them together. That's sort of, it gives us kind of an automatic transaction. We can touch a bunch of tables in a bunch of different ways that would be hard to do in a single query. We can use multiple Postgres features that we wouldn't otherwise be able to use in a single query, that kind of thing. We can write more readable code. But one of the main reasons to write a function isn't just an abstraction over transactions. It's also to create automated behavior. So we create automated behavior with triggers. And we'll get into triggers now. Triggers run functions automatically. So what that means is when another query is run on a table, it can trigger a function. So we can make a new trigger that says, hey, before an update on this table, run this function. So if we catch it before, that means we can actually change what that update does. Or we could actually update multiple tables based on that same update. We could inform a publish subscribe channel that something's changed over here so that users get live updates. We can do a lot of things with a trigger. It's useful for logging, updating other schemas, informing users, and maintenance. So if we're inserting logs, we could just say, oh, okay, we're gonna truncate these logs, or we're going to, okay, I've got over 1 billion entries in this log table. I'm actually going to dump that to a CSV file and truncate what we've got, or I'm going to do whatever. So you can have these automated behaviors. You can also use it as an abstraction if you use before or instead of. When the user does something, they think they're doing this simple thing like adding a row to a table. But we can say, instead of doing that, do this completely different thing. And So it uses that table then as an interface for the developer to do something. So say your design started off as naive and now it's in production, and you actually need to do something much more complicated. A trigger could get you there without having to change any of your application code. I want to visit a very specific type because it's near and dear to my heart. JSON types are great because the web has pretty much adopted JSON for everything, or XML. And the XML types are very similar, but XML is a bit older. JSON, I can dump an API from somewhere and get a million rows of JSON from NASA on pretty much any topic that NASA keeps data on. And it's fun to just dump this into a table. So we can store JSON as a column in a table. That's a lot of fun. And we can then query within the JSON objects as deep as we want. We can say, hey, if this field exists, go into there. I think it should look like this. If this is in there, then grab this, and we grab some value like way deep buried in the JSON and select that, or use it in a where clause to say where this object has all these fields and has this deep object in here, and it's at least 10. We can do weird things like that. And we can actually create JSON. We can say, hey, actually, when I select from this table, what I want back is a single column and single row of the results. Then it's just a JSON string. This one column, one row is just a JSON string, and it's an array of all the results. Great. I could do that with an SQL query in Postgres. Usually you do that on the application side, but sure, you want to do that at the database side, go ahead, knock yourself out. And there's reasons for generating JSON at the application side, and I'll get to, or at the database side, and I'll get to that in a moment. But generally, you do that on the client side. So this is really fun for exploring like data dumps. And let me just open up some of the functions you get access to. So if you use this operator on an int or a text in a JSON, you'll get back the thing inside of it, right? And if you use this operator, you'll actually get the text or the JSON type. And if you use this operator, you'll get the, what's that for? Oh, the path. So you can actually just specify a path and go down that path. So there's some basic operators, some more operators for determining essentially like in a where clause statement, like does this contain this other thing? And is there text that looks like this thing? Or can we merge these two JSON values? And that kind of stuff. And then there's other functions that turn other things into JSON, or turns an array, different types into JSON, turn a row into JSON. So if we like select a row that gets us, so if we had a select statement in here that gave us 1 and foo, it'd give us this, right? So and there's different ways of getting values into JSON, because we might want it to be structured differently. So there's a lot of JSON features, and it just really keeps going. And I find it really powerful because we can dump data, not care about what it is, but really use all the features of a database that is strongly typed, and use the functions as that are for a strongly typed system with loosely typed data. So.
Can I ask?
Yes.
On that point, if you have a date somewhere in a JSON object,
Mm-hmm.
can you interpret it as a date without having to transform it from a string to a date?
Yes, you can interpret. So that's, yeah. You don't have to like run a function that says turn this into a date. You can just cast it in place. So you can be like, hey, this field in this field in this field, : date, and it'll give you a date object back. Now, it might give you a null date object back if a null back if it didn't, know what it was, or it wasn't able to interpret it as a date. Any other questions about JSON or any of the previous topics? So here's a fun example to put it all together. I did this blog post 4 years ago called A Hybrid Data Store in Postgres. And let's just go there real quick. Nope, that sure didn't do it. 1 second. So creating a document store hybrid in Postgres 9.5. We're on version 11 now, and I wrote this in 2016, so 3 years ago. So I grabbed a bunch of data from NASA, and I dumped it into a database, and then I made, so I said, okay, there's an ID, and there's, let me blow this up a little bit. There's an ID, and I didn't, the ID was set as like a UUID or something. And then we had the JSON blob, and when it was created and when it was last updated. And then I made, in order to have the updated field work properly, we'll have to make a stored procedure to hook it up. So now, whenever you update the row, it automatically updates the updated field. So that's a use of a function. We create this function that is triggered before an update on patents. And it goes, okay, well, if they update the patents, then we set updated of that row to now, whatever time now is. So here's just some JavaScript of loading the data in Node. We don't care about that. We don't care about that. So now let's make a put and a get. So we can get the patent with this function. Just returns this query. And here's us selecting a category from get patent, the patent ID. So we can just say, give us a category of that, and it says, okay, aeronautics. That's our result. And then we have a put where we put it by the ID, and we insert, and then we say, oh, on conflict, so if that ID already exists, do an update, and we return the ID out. So we can select put patent, and we get ham back out because we said the ID was ham. So the hybrid part. So far, this is really basic data store in a database, document store in a database. But the hybrid part, we can set the category on the table based on the data category. Every time someone inserts or updates a patent, we can normalize the data. We can pull one of those values out and put it in a table. It doesn't have to be this. In this case, it's the same table that the JSON is in, but we can put it in a different table. We can have a completely normalized scheme somewhere. So we can keep everything in sync by saying, let's see, what is this? We've got a completely normalized table here of innovators. So when somebody does an insert or update to patents, we go and pull out all the innovator data from the patent and update a table with it that we have. So we insert into a table. And then on conflict, we can do nothing. If that innovator's already in there, we don't do anything. So yeah, now you can just sort of, you can keep a normalized copy, and then anytime you change the JSON, it updates your tables, your normalized table as well. Here's another case. Make a dependency, flattened dependency trees for a specific object that was straightforward with a CTE. So the CTE does reverse dependencies. So our modules, let's see, it joins back to the original to get the next module. Let's see. So when, I'm not sure. You can read the blog post. It's kind of hard for me to do this as part of the talk. I apologize. But we can normalize things that maybe turn something that we used to have to walk as a recursive query into a flat table of results. And we could do that dynamically. And we could say, when they add data to this, I actually want you to walk this thing and update this table. Curious, what was the bonus example that I wrote? Oh, it's just like my authors and books. Oh, this produces some pretty JSON. This walks, okay, so this doesn't use triggers or functions, but it takes our authors and books and aggregates it all together to create a JSON result as a string. So instead of getting the table results, we get a JSON result. Let's see, I lost my mouse, there it is. Publish, subscribe. Oh, here we go. Publish, subscribe is a pattern you see a lot with a lot of protocols, where you basically have a channel and you publish things to it, you publish new values to it, and if you're subscribed to that channel, you'll get those updates in real time. Well, Postgres has this built in. It's kind of a kitchen sink feature. It's, you know, we've got a connection to a database already, why not give us publish subscribe channels? So you can actually use this to great effect. You can say, for example, when something is inserted into a table, we'd have a trigger, and maybe that trigger adds it to a log, and maybe of notifications. And we also publish to a channel that, hey, something was added to the notification log, or this was added to the notification log for a given user. And so the users can subscribe to those things through a WebSocket or something and get updates in real time based on database triggers. We didn't have to do anything at our application level. It was just because something was inserted into our database, whether directly from the application or some maintenance process or some trigger, doesn't matter. That table changed, we're informing the user about it.
So the channel is not an element within Postgres. This channel is external to Postgres.
No, it's in Postgres. They have a channel feature in Postgres.
So there is a construct of a channel. Okay.
Yep, and it's separate from tables. It's a kitchen sink feature. It's like, hey, we've got this nice database here. It'd be cool if it also had publish subscribe, I guess.
Is the channel kind of acting like a FIFO, or?
You can make it act like whatever you want. You can publish whatever you want to the channel. And you can do it with triggers, or you can just do a query that just does that, or you can, it's really just a construct that you can use however you want.
Almost like a socket, one element sends to it, and multiple things can receive from it.
Right,
And
right,
if,
exactly.
If there is not a receiver at that moment in time, then
it's gone to the wind.
Gone to the wind, okay.
Yep. And so you would want to use this maybe in conjunction with a notifications table, and you would basically say, hey, you might want to check the notifications table, right? And then the user app would go get it. Or you could say, hey, there's this notification, but really, if you wanted to do this atomically, you should check the notifications table. It's really, really hard, and this is a tangent to Postgres, but we found in application design, it's really, really hard to give updates that are accurate because things change. There's latency. They get the update days later. It's much easier to keep a log of changes. Hey, this row changed. Hey, this row changed. Hey, this row changed. That applies to these users, and then you have a join table of users that care about it, right? And then the updates you're pushing back are really just, hey, you should check your notifications to see what's going on. Because that big log of things, maybe the same row got updated 394 times. You don't want to get 345 this row is updated changes if you're just getting back to it after a day, right? You just want to get, hey, that row changed. So you can use an aggregate or a group by clause to do that. And so Anyway, publish subscribe channels are just kind of a kitchen sink, like an extra thing that you can have that you can have access to in Postgres. It does all these other things. It might as well do publish subscribe. So I did this blog post in 2015 that said, hey, publish subscribe is better if you use JSON because that's what you're going to deliver over the WebSocket anyway. So I said, hey, there's this table update notify function. If there's an insert or update, it grabs the ID from the insert or the ID from the update. And it publishes to a channel called table update. And it builds this JSON object saying what the update was, what the operation was. And then we add the triggers to do that. So if they insert, they update. They update, they insert or delete, it will publish that change as a JSON string so that it's consumable, that the application can just relay it to the clients, and you don't have to think about, you don't have to translate the data type in the application. So that's just a fun little aside use of channels. Optimizing. My query is slow. Now, how slow is a slow query? A slow query might be 1/4 of a second. That might be too slow because if you have one thread, you're blocking everything else, or you're taking up resources that others can't use. So it's not necessarily just about the time that it takes to happen, but it's the fact that you're keeping the CPU busy for 250 milliseconds or 100 milliseconds. And on a database that you're doing lots of reads on, that's not cool. So what do we do with slow queries? Well, we explain them. So we use the explain command, and we just say explain, select, blah, 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 your query. You know, your big, giant query that joins to 27 tables and does all these aggregate functions and everything. You're like, why is this slow? So the explain will tell you how long it took to interpret the query if you're not using using optimized queries that are pre-compiled. Okay, so how long did it take to interpret the query? How long did it take to make a plan to run the query? Because unlike using like a data store, this thing is doing all the planning for you for how to filter the results. It's not doing, you know, a map reduce every time. It's not going through every value every time. Sometimes it's looking at an index that you made for it. So really, what happens oftentimes is when a query is slow, it's not using an index, or there should be an index there that really makes these lookups faster, because it'll tell you what the strategy was for getting the query back. And literally the worst one you can get is, I dumped this to a file and I ran grep on it. It can get that ugly if it's like terabytes of data with no indexes, and you just said, which string is like this string, right? So it can get ugly. So you should make an index. Okay, this query is slow. It's not using any indexes. Let's make an index. So let's go over using explain real quick. And this is just directly from the documentation. I just want you guys to get a look, just a general idea of what this documentation looks like. So nice thing about the Postgres documentation is really well written. It is true of SQL for the most part, almost everywhere. If Oracle has the same feature, it's implemented in the same way. If MS SQL has the same feature, it's implemented the same way. They try to keep things, all the databases that do SQL try to keep things in parity. They're not perfect, but they're pretty close. So when we do an explain, it will give us back the query time, the query plan, and how long it took. Explain a simple select star from a table. Okay. Well, what we do is we're scanning this table. The query, you know, and here's how many rows we're going to get back, and here's the data width. But it can get more interesting if it says, here's our query plan. We're doing a sequential scan of tank of this table and we're filtering based on this. It doesn't mention using an index anywhere. It's doing a sequential scan of the whole table and saying, hey, is unique 1 less than 7,000? Next row. Hey, is unique 1 less than 7,000? It's doing that for everything. So but what if it had an index? Now it'll say, okay, it's doing a heap scan, and it's checking the condition, and it's using an index. Perfect, it's using an index. That's going to make it much, much, much faster. So your cost will change. Your cost will be much less because it's using an index. So let's talk about indexes real quick. Indexes are separate files that are maintained, and these files can be of different types. They might be hashes, they might be whatever, but they're a separate file that's maintained when you add or update a row, or even remove a row. And it says, hey, all the values that are like this are this, or here's a B tree describing this particular column. And you can have functional indexes too. So the index value doesn't have to be a column value. It could be the result of an evaluation. Like you could index based on a path in a JSON object or something else. So you can do a functional index that's based where the value is something else. So different index types are useful for different optimizations. And these are things you can look up to get into. There's B trees, hashes, gists, a couple different kinds of gists, gins, which are useful for container types, and brins, which are useful for giant tables. You can index by multiple columns. You can say this single index is an index of this column and this column. And it's only going to use that index. That index is only going to be useful for that if your where clause or your group by clause is referring to both of those columns at the same time. So be careful with multi-column indexes, and use explain to make sure it's actually your query is actually using it if you want it to be fast. And again, indexes are typically done when you have a where clause or a group by clause. Some sort of clause that says we're using these columns, we're filtering, we're grouping by these columns or these values, and it will find the index that uses those and use that. Indexes add write time to your table. So when you write to a table, you insert or update on a table, it has to also update whatever indexes you have on that table. So you want to be really targeted if you're optimizing your application. You don't want indexes that your queries aren't using, because that's extra write time on your table. So in order to optimize if your application feels sluggish, look at your queries, run explain on them, see what indexes they're using and not using, create indexes where needed, remove indexes that aren't being used by any of your queries.
On the last point,
yes.
With old applications, I've wondered, are we still using the indexes? Do you know if there's any way to find out other than reading all your queries?
So you can, there's a query log, and you can aggregate your query log to find unique entries or unique types of entries in your query log, and then get the timing in the log from those queries.
I wonder if there's any log of index accesses.
There might be. There's a lot of internal tables in Postgres that you can query that kind of thing in. So if that's a need you're imagining right now, I bet there's a way to look it up. So I don't know the answer to that, but I imagine there's a way to do that. So using Postgres in an app. When you write a query, you're going to have to include values from the outside world in your query. And a query, according to your programming language, is just a string, right? So if you're generating a string from outside strings, those outside users can inject bad things into your query. So your query might be a simple select, and then they say, well, my username is actually end quote semicolon delete everything from this other table, right? You know, the input that they give you could change your query to do things you don't want it to do, and that's called SQL injection. So practically every querying library for an SQL database has SQL injection safe ways of putting user values into it. And so make sure you're using those correctly. Don't just generate a string and pass it to the query, to the library to run as a query, because you will get user injection and they will find out all of your users' passwords or whatever. This happens all the time. So you just need to be aware that you're using those features correctly. You'll get back whatever your list or array type is in your programming language. You'll get back a list or array of columns as your result. And unless you've said, oh, I'm going to JSON aggregate and JSON objectify all of this, right? And you'll get back a JSON string inside one of those rows, columns, right? But in general, you get a table back, a list of rows of the same type. Make careful use of transactions. If you're saying, get this value, based on this value, do this other thing, if any of your queries have to be done atomically together, put a begin and an end before and after them so that it's a transaction. And there are other ways, there's lots of ways of managing failure states and transactions and things like that. But the basics of it is begin and end. The other way atomic, and somebody mentioned it earlier, but an atomic action could fail if one of the parts fails. So if you're inserting along in your transaction, and then you do a get, and then you do another insert, or whatever you're doing, and one of those fails along the line, you probably want to undo everything you just did, because that atomic action failed. And you can recover from in a lot of different ways, but in general, your transaction failed, you want the whole thing to not have happened. And because, remember when we first started talking about Postgres, it's a multi-version concurrent system. So it's literally forking your table every time to add the change. So undoing the change is no big deal to it. If you properly use transactions, it goes, okay, we didn't do all that, great. Use an ORM if you want to. And I'll talk more about that. An ORM is an object relational manager. It's essentially a way of using whatever your native language functions are to generate a SQL function so that you don't have to know SQL. I recommend that you know SQL anyway, and I have some hot takes on when and when you shouldn't use ORMs. And my hot take is use ORMs minimally. When would you use an ORM? A great time to use an ORM is if it's a CMS. If you want to it's a content management system. You want to automatically generate all these forms and admin panels for the users, use an ORM because you're literally describing the data in the database to the point where it can create forms to render for you. So you don't have to write any of that stuff. Great, that's a great use of an ORM. Ruby on Rails, Django, great for CMSs, for content management systems, like a newspaper or whatever, where you're generating data to render on a page. You could, or anything where you want to generate forms automatically. You don't want to be bothered with doing that. ORMs are great. But keep in mind, you have no idea what query it's generating unless you go look. So you don't know how to optimize that query unless you go look at the query that it's generating. In some of these systems, they'll like make the tables for you, they'll make the indexes for you and all that. You don't know if they're doing a good job unless you go look. So I really, really, again, recommend that you learn SQL, even if you're using an ORM, because you get to learn you only have to learn SQL once. You have to learn every ORM you touch for the rest of your life, and they're all different. So we have an ORM that we use at And Yet called Muckraker, and it was, we iterated on these like object query binding things and ORMs and stuff for 5 or 6 years, and then we found, ORMs are handy for really simple use cases. I want to select these values from this table on this simple where clause, and you just say, you just call table name get these values or these values. Great, you pass it an object. That's great for that. ORMs are great for that. As soon as you get, or I want to insert this set of data into a table. Great. ORMs are great for that. As soon as it gets more complicated than that, you're generating a complicated query that you have no idea what the ORM's producing, unless you go look. So I want to look at Muckraker real quick. So what we do with Muckraker is like it gives us, once we connect to the database, yada, 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 we can use a find query, right? And it creates a where clause for us. And it just gives us all the users that match that where clause. But if we want to do something more complicated than that, and I guess it probably mentions this in the text somewhere, if we want to do something more complicated than that, we have a directory of SQL files that are templatized to take in incoming values, and we just say, hey, make a function for each one of those SQL files. And so we're literally anything more complicated than one table and a where clause for an insert, update, or delete, and we just reference a file that is the SQL. So we write the SQL directly. We found that to be the best pattern for us for anything that's not a CMS or anything where we don't need to generate the forms for us. So basically, single page web apps, this has been the best pattern for making an API for us. When we have a simple query to write, sure, just use a built-in function. If we're joining, if we're doing crazy stuff, then just build a function based on the SQL file that it finds. Oops, I didn't mean to quit. Command Q instead of Command W. Let's see how well it recovered. Let's see. I need my notes. Okay, any questions on ORMs or query generation or query optimization?
When you say you put the SQL in a separate file, is there some sort of method where you call that file like it's a function?
Yeah, so when Muckraker starts up, we pass it a configuration object, and we say, hey, look at this directory of SQL and make functions for all of those.
Okay.
So, and then it turns those into template functions that don't allow injection, and we go from there. So that's just part of the library initializing, is it? You point it at a given directory.
And then you take those files, suck out what it used, and use that in your code?
Yep.
Okay, not that you're using that file live like it's some sort of library.
Nope. Okay. No, it just loads all those files in as template objects. It converts them into template objects. And then when you call a function, it goes, I've got a template object for that function. Great. Okay. And it generates a query. So a lot of our queries end up looking, in that case, like I like to make functions and store them in the database, but it's inconvenient from a migration perspective. We'll get into that in just a second. So sometimes we just write anonymous functions. We just say, oh, here's the function. It has no name or whatever, because we're running it right now. We're declaring the function and we're running it. So we don't give it a name. We don't give it it's just an anonymous run right now function. So sometimes we do that. We don't do that in cases where optimization really matters, though. Okay, so migrating. I have a lot of opinions on migrating. Migrating is a traditionally hard problem in an SQL database. But there's a beautiful pattern that for data structure makes it very, very, very simple. And a lot of tools like Rails and stuff includes their own migrating stuff. One of the ways that it's done is you have an up function and a down function, and then you have a bunch of migration files. And so when you move forward through the migrations, it runs all the up functions. When you run backwards through the migration, it runs all the down functions. So you say, okay, well, I created a table today, and here's my create table statement. Put it in an up function. And then you go to the down function, and you say delete that table. So when they go to that day's migrations, when they're migrating the database for that migration, it builds the table for you. And whatever indexes you set, and triggers, whatever changes you made that day, it runs. When you say, oh, I actually want to go to this previous migration of that, it runs all the down functions until it gets to that day. Sorry, Chad.
No, you're good.
So one of the opinions that I have about migrations is that you really, really, really should write migrations. And they really, really, really should be able to be run by every developer on your team. And your developers on your team should be with just a couple simple commands, looking at the README of your project, be able to stand up the database and migrate to current. That should be a 2-command thing that's in your README. They should be able to run it locally or run it to their assigned database. Some places like P&L doesn't let their IT staff run MSSQL on their servers, so they have to say, oh, can I have this database? Great, you have a database, but it's that user's database. You shouldn't have, your developers shouldn't be sharing a non-production database. It should be individual per developer, because they're forking and branching the code. Who's to say that that code lines up to the database in that state? You're just going to trip each other up continuously. One of the ways I've seen it solved is that, only one person is allowed to touch the database. They are the team's database guru. And I think that's a bunch of BS. And we should just give people the tools they need to be using the version of the database that lines up with the code they're using. Yes, Chad.
I was just going to mention that migrations actually does help the problem, at least identifying it. If you're a developer and your code base is on migration 5, and the database says I'm on migration 7, it at least warns you that your code base doesn't match the centralized database.
Yeah, it can, depending on the tools you're using.
Right. And so it doesn't, but at least you know that if something happened, you may not know what it is until you either pull from them.
Right. So yeah, shared developer databases are bad. Right now we're using something called Connects.js. It's a big ORM we used to use. We don't use it very much anymore because we use Muckraker, but it had a built-in migration tool that was very, very good. So we're still using that. And eventually we said, well, actually we could make a slightly better migration tool and not have to load this giant ORM just to use the migration bits. So we're working on a tool called Red Crab right now. We're almost done. We're on slide 43 of 46. Clustering and sharding. So Postgres traditionally didn't do any sort of clustering other than master-slave sorts of primary nodes, secondary nodes, clustering. But Postgres is very, very extensible, and so companies like Citrus made their own clustering extensions. So that's changed in recent years. They've started to add clustering features. So one of those clustering features is called data partitioning, or otherwise known as sharding. In 1998, when Ultima Online came out, they said, oh, our servers are too small to run all of our users. We'll invent this thing where they all live in a crystal, and the crystal got broken into pieces, and now there's shards. So that's where we got the idea of shards. It's from an MMO from the 90s. But anyway, so data partitioning or sharding. You can combine two features right now that are pretty new in Postgres core. Well, foreign data wrappers have been around for a while, but you can do data partitioning in a table. You can say only store data from this customer in this table. So you have a customer ID or whatever, and that only gets stored in this data shard. It'll automatically create new shards for every data customer. And when you query it as the base table, and it'll go across all of them. And then you just say, okay, use foreign data wrappers to say these tables are actually on separate servers. And so the master for those tables is separate. So your primary node for writing for those tables can be separate. It's a bunch of work to set up, and that's why I say, like, when you're writing a ton to a database, more than the performance that you just can't get the performance for what you need for the number of writes per second. It's a bunch of work to get these, tweaked and set up, and then have a maintenance plan for like what happens when one of the nodes goes down. How do we automate that? What do we do, right? So that's a bunch of operational setup. But then there's also Citrus tools, and they just have a bunch of tools that help you do that. To make it simple, you're going to be paying them a contract fee, of course. But at least the functionality is starting to make its way into Postgres core. So yeah, that's why I said earlier it's a decision-making process. When you get to the point where you need to cluster your writes, you go, all right, how am I really going to do this? Am I going to move to something dumber, like a document store that just lets me write it anywhere, but I get conflicting results? Or should I jump through these hoops and set this up so that I have partitions on my tables? And then, so a lot of features have been coming to Postgres dealing with multiple servers, optimizing big queries, multiple processes and multiple threads. So really taking advantage of multi-CPU processes for Postgres. And that kind of has been working in the background into their clustering features that they've been working on. Right now, it takes a lot of setup, but it is there. Let's see, we're at Q&A time. Does anybody have any questions? I haven't been asked already.
I got one.
Yeah.
Don't like keeping calling names for this, but why would I choose this over like something like Firebase if I'm a hobbyist and I have a full-time job and I need to spin something up quickly?
Sure. Firebase.
Or something.
Sure. Yeah. Firebase is good for simple things where you don't mind paying and you don't need to scale super high, because you're going to be paying out the nose when you start scaling super high. Yeah. So I guess I could have put that in the don't use Postgres if it's really simple and really small and nobody else is going to use it and I just want to use Firebase. That's okay. You're not using all the advanced features or whatever, and you don't want to run it yourself. That's fine.
Is there a equivalent like for Postgres, like DigitalOcean?
Oh yeah, there's lots of Postgres services. In fact, there's a variety. Like Amazon has a couple of different Postgres services that you can spin up, and they have this old fork of Postgres that's been merged. It's Postgres compatible. It's called Redshift, and it's for big data sorts of operations and stuff. So there's all sorts of Postgres software as a service. Heroku has one. Everybody pretty much has all the big hosts. Azure, Microsoft Azure, and Google Cloud, they all have Postgres.
Again, this is in the context of getting something spun quick.
Yep, and you can just say, hey, spin this up for me.
Amazon Aurora does that too, Postgres.
What's that?
Amazon Aurora, it does it with Postgres or MySQL.
Okay, yeah, the Aurora service. Mm-hmm. Yep.
So how does Postgres compare to MySQL for performance?
For really the Postgres has more index types. MySQL has pluggable backends, which is a feature that Postgres doesn't have yet that they're working on. But generally, performance is going to be pretty much equals. So it's, the biggest reasons why I don't bother with MySQL personally is because it has a lot of automatic casting that can trip you up, typecasting and things like that. It has a lot of little things that can trip you up that you don't expect. But mostly it's just it doesn't have that many. It doesn't have nearly the feature set that Postgres has. And so if I'm going to go to the trouble of spinning up an entire database service that I now have to operationally maintain, it's going to be Postgres over MySQL.
I can't remember for certain, but doesn't Postgres have like a grid generator?
A grid generator?
A GUID, or a random or unique ID generator.
Yep, it has a bunch of them.
Yeah, that's all.
Yeah. Yeah, so it has a bunch of types that you can do that with, and then I've made my own like weird index type that, yeah. You can go crazy with like primary IDs or indexable types. Any other questions? Yeah.
I have a longer backstory to this that I like CouchDB, but I'm wondering, does Postgres have an HTTP accessible changes feed?
Not directly.
It sounds like you described already how you can emulate that, but
Yeah.
I wondered if, how built in that sort of functionality might be.
It's not built in at all. So the pieces are there to do that yourself. There's third-party tools that do that. It doesn't have that built in at all. It's not designed to be exposed to the web in any way. So yeah, I think CouchDB is really interesting, and it has a few really niche use cases that it does very well, particularly with like network connectivity not being on all the time.
How hard is it to upgrade between the versions? Is there a lot of breaking changes they typically introduce, or do they try to do it in a manner that is backwards compatible friendly for 98% of the?
So yeah, in the release notes, you'll see any break. It'll give migration instructions for anything that's breaking. I haven't seen anything breaking in years, and they iterating on it. We just went 3 years from 9.5 to 11, and lots of releases between then. It's not typically an issue. Generally, it's fixing bugs, adding features, not reworking something old to be different. Yeah, so they're really, really careful. Like MySQL and other SQL databases have had what's called upserts for a really long time, but they couldn't figure out a way to do it. They took like 5 years to figure out a way to do it safely, whereas MySQL doesn't do it completely safely, and other databases don't do it completely safely. Like they were like, we don't want to redo this and have breaking changes, so they took their time to come up with a safe way to do it. So they're really meticulous about that. Just the whole philosophy is do it right the first time. And so like one of the big things coming up is extensions for backends, and I think we probably won't see any breaking changes, but like that's like got the potential for it, sure. But I've never seen it affect me any.
To add a data point to what you said there, I had a recent, I went from 9 to I think 11 or something, and I just told it to do dump at the command line on my one server and suck it in on the other server, and everything was hunky-dory.
Yep.
I'm using an ORM in the background, and I'm doing some pretty simple stuff, but did that just this year. And
yep. Yeah, I mean, where you might find problems like if you're using an exotic extension that's not part of the contrib, like not a contrib extension, and they don't update that at the same time that the new version comes out, that's probably where you'd be tripped up, is using a third-party extension that's not in the contrib library.
But as far as core, they're pretty stable across the board.
Yep. All right. Thank you very much.
All right, guys, thank you very much for coming. Next meetup is May 1st. Somebody will be talking.